Hello, I'm Gard. I'm working in a company named Schibsted, which is a European company. We have several news sites and marketplaces all across Europe and in Southern America. We're quite a big player in Europe, especially in the Nordics. In Norway and Sweden, we reach more than 70% of the population on a daily basis. So that's quite impressive numbers. We started out playing with Spinnaker in 2015, and we launched it in production in 2016. We have about 300 active users in Spinnaker, developers doing deployments and stuff like that. And we are 4 engineers in the pipeline team at Schibsted, and all of them are here. So in this table, we have the rest of the team. So what's our mission? Our mission is to promote CD and build infrastructure to support it. So it's established fact that if you have small deployment deltas, it's easier to debug errors in production and bugs in production because you can easily identify what's wrong. So we want to keep the deltas as small as possible. We want to give the users quick bootstrapping of their applications. And quick is kind of 2 things. It's fast, and it's also kind of a quick mental exercise. So you shouldn't be needed to read 10,000 documents in order to be able to do it quickly. And we want to have cheap maintenance. So we should handle everything that can be handled centrally, so that all the developers don't need to care about nitty-gritty details about how pipelines are created and how we're evolving the platform. They should be concerned about writing application logic. So a consequence of this, or a driver for this, is standardized infrastructure footprint. If we want to centrally make it easier and more like a product feeling, we need to have a standardized footprint from all the applications so that we can do central changes and not kind of work with unicorns all day long. And we want transparency. We want to be able to see who deployed what, where, when. Oh my God. And we also want to be able to navigate like from the Git system or from the kube control clusters into Spinnaker and the other way around. So we want to be able to go like navigate from the different parts of the ecosystem and between the tools. So keeping the deploy delta as small as possible, I touched upon the bug fixing part. Make it easy and fast to fix bugs, but there's also a kind of very boring part, which is the business side. And if you're developing a feature, it's mostly because you want to make the organization more efficient, so you earn more money, or make more money, or save more money, and also features that actually bring in money. So if you're deploying all the time, every commit, and you do changes that helps the company earn more money, the time from the commit being done until it's in production is a holding cost. So you basically want to leverage the new development as fast as possible. So that's why we believe that continuous delivery is critical to be competitive and get a lot of money. A consequence of doing this is, of course, small deployment deltas, which makes it easier to maintain whatever we have. We measure this quite well, because if we look at how many deployments Spinnaker does in our environment on a weekly basis, we see that it's roughly 3,000 deployments a week. 400 out of those are to production. A typical application has 3 environments: dev, pre, and pro. So we want to have 1/3 of the deployments to be a production deployment. But when you take 3,000 and you divide it on 400, or do some math there, you see that it's not 1 out of 3. So currently we are basically roughly around 1 out of 8 deployments goes to production. And this means that 1 out of 3 commits goes out to production in Schibsted through Spinnaker right now. So this is an indicator that we think is quite interesting to measure the deployment delta. So 1 deployment to production in Schibsted right now probably contains, in average, 3 commits. I talked about how we want a uniform platform in order to provide tooling and help to the developers so that they don't need to concern about all the nitty-gritty details. So our current stack, or golden path, consists of these tools. Many of them are quite familiar to you guys, except the guy with on the right, upper right corner there. So it's Git. We use Git for VCS, Travis for CI, Artifactory for artifacts, Spinnaker for deployments. We have this crazy guy on the right corner, which is our PaaS solution. It's basically a layer that gives a small contract for the users to be able to deploy to Kubernetes. I'm going to touch more upon that later. But here, I think all of you has just got one unknown here, which is that FIAS guy. So what is FIAS? It's basically a system that gives you a very small footprint against the infrastructure. So it's driven by defaults. And given that you're following all the defaults, your manifest for deploying the application is basically a version field. Then you can get your application out and it will run. But this means that your Docker container starts with the port that is the default port, and the health checks are available at the default health check URL, and that your Prometheus metrics are available in the default path. But given that you have this, we will create DNS name based on the application name, and we'll scrape Prometheus, and health checks will be auto-generated, and everything. So FIAS takes this, the example here is a little bit more than the version field, but it takes this, data and then expands it into horizontal pod autoscalers, deployment objects, services, ingress objects, and deploys it for you. So if you look at the red boxes here, you have the input on the left side, which is a little bit of data, and on the right side you have the expanded and hydrated Kubernetes manifest that we deploy. So if you want to know more about how we do this and how this stuff works, you can reach out to any of us from Schibsted after the talk, or you can also go into the GitHub repository there and have a look. Yeah, I forgot to say in the beginning, you feel free to stop me in the presentation and ask me questions. Okay. So FIAS helps us have a small DSL to create Kubernetes objects, right? What you need to run this is like in the CI system, you need to upload the Docker container. You need to build a Docker container. You need to upload some pipelines as code and the pass file. And we've created helper methods in our CI system to provide all those scripts and hacks to get this out. And application, a Java application in this case, has its kind of unique Gradle command to produce the jar files you need to have in order to build the Docker container. And then we just run the pass upload command, which is taking care of all these common nitty-gritty details. This is the Docker example. So when you run the pass upload command, we build the Docker container based on the Docker file you have in the repository. And we tag it automatically. So this tag is quite neat. So we inject the Docker registry, and then we set the Docker name for the container, the name for the container, is the full repository URL. So in this case, the delivery team is the GitHub organization, and some service is the service name or application name. This gives us kind of the bidirectional visibility as well. If we go into our Docker registry and we spend a lot of disk on one kind of Docker container, it's easy to see which repository is producing these Docker containers and kind of navigate back to GitHub and find the owners and this kind of stuff. We also set the Docker tag automatically. It's just a git SHA and the timestamp at the end. But this kind of removes the need of creating 250 million ways of making Docker tags unique and that stuff. It's just provided in the helper scripts. We're kind of doing the same for our YAML files. YAML files is a little bit different than Docker and Maven artifacts or jar files and this kind of stuff, because you don't have the default kind of package management tool for YAML files. So what we saw in the early days is that when you're uploading a YAML file to Artifactory or whatever store you're doing, it's easy to upload. It's hard to do the error handling and everything. And if you do that in every repository, it's kind of bloated. So our helper methods uploads the YAML files automatically, and they're doing about the same thing as the Docker naming that we're doing. So we're taking the path, the repository org and repository project, and then on that path, we upload the artifact as the file name, and then we add versions, like we're using semantic versioning on this because it doesn't make sense with SHAs and this kind of stuff on YAML files. So we're using the Travis build number and Travis job ID as versions. So, and we have the error handling and this stuff covered here. So that means that the developers doesn't need to care about how to get the YAML files uploaded. It's provided. Then we have the declarative pipelines. I talked about how we do the Kubernetes objects or the pass manifests and upload the files, but we also, yeah, so when we have the pipelines as YAML, we resolve them, as I said earlier, we upload them as artifacts to Artifactory, which means we are not targeting the VCS system or pipelines that are living inside Spinnaker. They're living inside Artifactory with unique versions. So we're fetching from the CI build the information about which concrete version of the pipeline that was uploaded in that build, and using that to do the execution. This means that when we roll back, we will use the previous CI build and we'll derive the right pipeline definition from that. So we can always roll back and it will be the same pipeline that is executed. So we added some stuff to deck. We have our own deck, which is extending based on the node modules that are provided by Spinnaker upstream. And we have a few modifications. One of them is the create pipeline step, where we can select to resolve the pipeline from the CI build. And we have to put in what artifact type and artifact name it is for that pipeline. We could probably skip the artifact type because that's always the same. So this is our pipelines as code. As a user, this is what you do. You have to have this file, which references a parent template, which is provided by the pipeline team. If any of you were in the talk yesterday that Pedro and Jørgen had, you'd see more about what this parent pipeline looks like and how it works. And as a user, there's no problem using this. It just works, right? So to us, it's really convenient. We have basically got 4 unique fields here that you need to fill in, which is firstly the name of the pipeline, the owner, which is an email, and then it's the variables. We need to know what team you're in, and we generate the Kubernetes namespaces based on teams. So when you put in delivery there as the team, or namespace prefix, you automatically get deployed to delivery dev, delivery-pre, and delivery-pro. So that's how we do that, because there's no need to define it 3 times when it's always having the dev, pre, and pro suffix. And then we have the field for enabling or disabling the include manual judgment. There is a lot more overrides that you can use, but this is the kind of typical example of how a pipeline is done. This pipeline expands into 4 stages: deploys to dev, deploys to pre, manual judgment, and then deploy to production. The deployment stages, because we're using this internal tool FIAS, is not a typical way of deploying in Spinnaker. So what we're doing is that we have a service called MAST, which binds Spinnaker to FIAS. And this is very funny to us because Spinnaker is a sail, and Kubernetes is the boat, and we need something that connects the sail to the boat, and that is MAST. So this is the only kind of abstract service name that I like, actually. And what we do in this generate stage is that we send in the artifact reference for the pass YAML, and also a lot of metadata from Spinnaker, like what commit triggered this pipeline, what pipeline execution ID is this, which user triggered it, what CI build, and all kinds of metadata that gets bind into this Kubernetes manifest that comes out of this MAST generate stage. Then we have a stage here where Spinnaker uploads the manifest. So we get from the webhook stage here, we get a manifest ready to deploy with Spinnaker, and we're using the V2 provider. Why are we using the V2 provider here? Might be a little bit strange, but Spinnaker has the tracking and error handling of uploading Kubernetes manifest. And also it has the security parts, like this team is allowed to deploy to this namespace. So by doing this MAST service can be very simple and just be concerned about generating the manifests, while the Spinnaker Kubernetes integration takes care of the authorization part of this, which is, and also if there's an invalid manifest generated. So this gives us value. And then we have the last stage here, which is also a webhook stage, which calls the MAST service to look at the status of the deployment. Because the manifest we send in with Spinnaker is a CRD or TPR, depending on the cluster. And then the FIAS deployment system takes over. Much like Google had several kinds of deployment systems, we have our own, of course, as well. And MAST is binding Spinnaker to the status of that deployment. Yes, so I mentioned that we're injecting all kinds of annotations into the Kubernetes manifests in the MAST stage. On the right here, you can see that we have customized the Spinnaker UI a little bit. So we've added our own logo. So if it's a FIAS application, we have this, I don't know how to say it in English, but the captain of the ship or something like that. And we have a section here called FIAS. Here you can see that we have a deployment ID. This is internal to the PaaS system. Then we have a pipeline. It's not easy for you to read either. A pipeline, that's the link to the pipeline that deployed this version of the system. We have a link to the commit, so if you press that, you go into Git and you see the commit that was deployed. You have a compare URL. That's where you see the 3 commits that you asked about. But that's not relevant to the previous deployment, actually. It's relevant to the PR or whatever that did this. And then we have a link to the CI build. And reports, that's Quality Gate, our quality measurement tool. So you get a link to see how this application affected code quality. No, this commit affected the code quality. And we have links to metrics. And we're saying that it's Prometheus there, but that's not very accurate. It's Grafana, so I'm a bit annoyed. And we have links to the documentation. So you see we have FIAS docs, so that gives you the pass, how do I work with the pass information. And FAQ, so frequently asked questions. And the help center. If you want to raise a ticket or you have some kind of problem, you press that link. So here I've just done a kube control and got the object. And I just include this to show the annotations that we're setting. When I read it like this, I think we can do a better job because we have the pipeline execution ID, for instance, but the bidirectional traceability is not so easy to do, like use that ID and get back into Spinnaker. You need to know how Spinnaker works. So I think we'll have to go and change this a little bit so that you can actually get the link that you can press to go back. But this is some of the data. When I tried to include more data, it got even less readable. So I just cut it here to kind of make it look good. We have traceability in Git. So recently we had some hackathons, and Albert on my team, he started playing with status checks in Git. And eventually he created support for this in Echo. And this is kind of neat. So we can have all the stages or pipelines report statuses back to Git. And this works just like a Slack integration or the other integrations that we have for notifications in Spinnaker. And I love this. It's because I'm a pipeline nerd probably, but I think it's quite useful as well because you can look in Git, see what commits has been deployed to production, and you can also go into the link there. The details link is a link into Spinnaker, so you get into that concrete execution of your pipeline. What do we currently like about our solution? We like the declarative pipelines. It makes it convenient for the users to create pipelines, and we've gotten a lot of feedback, like it was the most requested thing to have pipelines as code. So that's one thing, and there has been a lot of complaints, like it doesn't really feel good when you're wiring up a pipeline by hand. It looks very quick when I do it because I've done it 10,000 times, but when the end user tries to do it and select 15 different fields in the deployment stage, kind of creates a lot of confusion. This has helped a lot on that part. We also, at least me personally, I love the traceability. I think it's super cool to be able to navigate from system to system and have this transparency, this linking between systems everywhere. And as a kind of large organization and a distributed organization with many tools, it's really convenient to be able to bind them together. So I think this is something we'll focus on for a long time to kind of have to direct traffic to the various tools, because it's hard to be aware of all the tools that is available in an organization. Another thing that we really like is the Kubernetes V2 provider. It has been a pain to take the Kubernetes journey prior to having that provider. We got a lot of kickback on the Kubernetes deployments using the V1 provider, and I didn't trust it. I knew that we would have many Kubernetes clusters at different versions, and I didn't believe that the V1 provider with a Java library handling the integration could support all of these. But with the V2 provider, I'm not afraid at all. I can sleep well at night because it uses kube control. And when AKS came out, we were able to just set up a vanilla kubeconfig file and make Spinnaker index and work against the AKS cluster. So I think that's a really great thing that has come out recently. Also, leveraging the authorization part is really good because I know it's kind of enterprise friendly. So what do we want to improve? We want to improve our kind of debugging of failed deployments. Right now, it's a webhook stage that just gives you an error, it's red, and then good luck check. We want to provide logs so the user can actually see what's wrong and linting and kind of proper feedback. We want to include config maps to our golden path. Currently, if you have a config map, you need to do some manual stuff to kind of include it in your pipeline. You can hook in with pre-stages and inject stages with declarative pipelines, but it's very hard. You need to be a domain expert in Spinnaker to do it. We want to just make that easy for the user. And we want to improve the automation of all the wiring. We have all this nitty, nice, fine helper tools in CI and everything, and you have this nice UI to wire up the pipelines in Spinnaker, but the user still needs to know about all these nice things. And that's a problem because the user shouldn't need to care about those things. So currently we're in a project where we're automating the flow from I have a repository to I have a walking skeleton running in Kubernetes with declarative pipelines and everything. So at this point in time, the solution works for enabling Travis, code quality instrumentation. And the Spinnaker part, we have a service that automates this, but we haven't still wired the glue together so that it's part of the same flow, but we're finishing that as we speak. And the interface for this is currently Slack. So we have something called product pitches, where we have to say how this will look. So I've taken a screenshot from our product pitch. Here Pedro has requested the onboarding. And this automation kind of gives Pedro Slack messages back on what's going on. It creates PRs with the new files and everything you need to get things wired up. And then it also wires up Spinnaker and creates the application and gives you links to where your application and pipelines are in Spinnaker. And it also automatically merges the PRs if the PR deployment is successful. So at the end, you've been able to follow this trail on Slack. And when it's finished, you get an email with a report on this. I think maybe it's a little bit strange that we're using Slack for this, but ChatOps is kind of a big thing nowadays, and a lot of people want that. But the solution we've built should, like we get the email and we can create a web interface or whatever. The important thing is that we are able to kind of automate this part. So I'm done now. Thank you. If there's any questions or anything, reach me on the Spinnaker Slack. Don't ask them here. No, you can ask them here.